Good afternoon. I'm Rukshan, student ID 20220856, and my UOW ID is W1954083. So, my presentation, my research is regarding on advanced malware detection, file uploading systems. So I'll be using NLP techniques to solve this problem. So during the presentation, I'll be discussing about these topics. So these topics are like under agenda. I'll be discussing research problem and research gap, then identification of project stakeholders, formal requirements, system design, overall systems architecture, updated time schedule, progress since PPRS, conclusion and reference. So that's my first topic, problem definition. So I'll be using a byte latent transformer to identify the problem. And also the current problems when I went through research papers, these I'll be using MalAPI 2019 as my dataset. So I'll be using Cape Sandbox logs. So those logs, those are malware behaviors. So when I went through past papers, uh, standard dynamic analysis treats API calls as separate events, missing crucial links between malicious functions. So the current systems, like they treats these API calls as separate events. So what? And also this will it's like this can easily trick the system. So whenever if we treat if we don't look for the connections between the patterns between the logs, then the system can be easily tricked, because now malware, like sometimes the attacker, it will wait for a long time and do a small activity like that. So, and also that's another weakness that I identified. And this weakness allows complex malware to evade detection by hiding casual actions for long time periods or across multiple processes. So, like what I said, they will wait for a long time and do a small action, and wait for a long time and do small action. To prevent this, I'll be using a byte latent transformer technology. So this can like wait up to like this is great for long sequences, to track long sequences. So I, as a technique, I'll be using transformers to solve this. So these are the gaps that I identified. So the first one is function interaction blindness, like what I said in the previous slide. So the current systems, they don't look for the connection between these blocks. And the second one is noise sensitivity. So malware create a lot of noise, like it will wait for a very long time and do a small activity. It will create noise to trick that system. And generalization and zero-day detection. So to identify this, and zero-day malware detection is another challenge that current systems are facing, and class imbalance. So when I went through during my implementation, uh, when I went through, like most of the data sets are imbalanced, and also they have been using duplicate data. So in the testing and the training, so the because of that, so model has, when we use testing data, so data has been duplicated. So model has seen this data before. So that's another problem that I identified during the implementation when I was pre-processing data. So when we move into rich picture diagram, so this is my rich picture diagram. So there will be ethical hackers. Then when it's come to uh, domain, like it's like this. So this system, since it's an NAP model, this system will look for new malware patterns as well. So whenever there is a new malware type, this system has to automatically, like if it does a mistake, the data engineers should capture these malware types and update the system. That's the main focus. And also, if we can do that, we can prevent malware, zero-day malware detection as well. Uh, so when it's come to stakeholder identification, when it's come to wide environment, the wide environment consists with CS firms, application, competitors, hackers, and ethical hackers. And the containing system contains with machine learning experts, computer scientists, and solution providers. And the system consists with solution providers and data engineers. So basically, solution providers are and data engineers will be the main uh, characters that they are going to play in here, because uh, they are the ones who give provide new ideas how to enhance this system to track latest malwares. And and most of the companies will be benefited from this, because most of the companies, if they have systems, like if they use document management systems, they have to upload files. So sometimes these files can contain malware. So whenever they upload the file into their system, so it can be a big threat. So to prevent that, this malware detection system is one solution. Is a one solution. So when it's come to requirements, uh, under uh, under functional requirements, these are the things that I have achieved during my implementation. So system should allow user to upload executable file samples like Windows binary or portable executable PE files. The system should be able to detect the latest malware. So up to now, since I'm using 2019 Mal API 2019, it consists with latest malware types. So it can detect like eight malware classes. The system should perform a deep learning based malware analysis on the file that have been uploaded and identified whether they are malicious or not. So, my main goal is to track whether this file is malicious or not. So that task also I completed. The system should be able to capture long range action. So this system can reach up to 512, which has a length of very long range of sequence consists with uh, very lengthy logs. It can capture very lengthy logs. So it can go up to like 512 different vocabularies. So since Manly API 2019 consists with 512, 447 different vocabulary, it was able to detect most of the malwares. So this is another section under in progress. I'll be using still the system should explore hybrid architecture is in progress, and also the detection system must continuously update. So it should be like what I said previously, like if it has done mistakes, it should update and learn new malware behaviors as threat change. So this can prevent zero-day malware as well. And the system should handle errors gracefully and display appropriate error message in case of any problems like input failure. So under non-functional requirements, the system should be accurate when detecting a malware. So it should be quickly it should be speed like it should be quickly detect. So in my case, the system, like whenever the sandbox logs were uh, input was sent to the model, it was able to capture whether it's malware or not within a short period of time. And the system must produce very few incorrect warnings. So it's under the second one is under in progress. So the system must efficiently manage and process very long API calls. So like what I said before in the previous, like what I said before, under MEL API 2019 dataset, it consists with lengthy logs, lengthy sequences. So since I gained a 71% of accuracy for that dataset, so it was able to successfully capture long range of API calls, and the system should be able to capture long range of actions. So my main focus is to capture long range of actions and look for the connection between the logs. So this can prevent up to a certain level of malware detection. And under non-functional requirements, again, the system should be able to clearly show security analysis. So it's under in progress, and the like under this section, the system should be easy to maintain and upgrade, accommodate new feature and improvements. So that has been completed, and there are another three more requirements that I should, another two more requirements that I should complete under non-functional requirements. So when it's come to UML case diagram, so basically what happens is the under a user there are like three categories like user, employee, and developer. What they do is they will upload in the, like if they're working in a document management system, what they will do is they will upload the file. So upload the file, and before uploading the file, it will check whether it's malign or not. So if it's malign, it will not allow to upload to the relevant destination. So what it does, like it will go through a malware, a sandbox environment, and get the NLP, get the logs, and use NLP to detect whether it's malicious or not. So in this case, like what data engineers do is like they will look for new malware types and update the model. And just in case, like if the system, if the malware model detect whether it's malign, then it will not allow to upload the file. So if it's a benign sample, it will allow the user to upload the file. So that's what happens uh, in my implementation, in my research. So when it's come to architecture, system architecture, so there will be three layers: presentation layer, logic layer, and data layer. So what it does is like I'll be using an Angular web dashboard for this, and I'll upload the file to Spring Boot backend, and from Spring Boot backend it will send to the Python server, and from that it will send the logs to the model. So it will send the sequences to the model, and the sequences will be pre-processed in a specific method, and I'll be send the logs to the hybrid BLT CNN. And what it does is like it will by hybrid BLT CNN, it will detect whether it's malign or not. So based on the behavior of the malign or benign sample. So this is my machine learning malware detection machine learning pipeline. So in the first step, I'll be cleaning the data, like data cleaning and pre-processing. Then the feature engineering happens. Feature engineering happens. Under feature engineering, I'll be looking for like in the model, it will look for common look for unique behavior which under those malware types. So add and replace relevant logs to identify easily whether it's under that relevant malign sample. And tokenization and vectorization happens. Then after that, training setup happens. Then it will go through a BLT and a CNN, 1D CNN layer. So 1D CNN is to identify whether this logs contains any unique behaviors, whether unique actions. So this will enhance the model. Perfect. And this is the project timeline. So September to October, selection of problem domain. So I was looking for a problem domain. Then November to January, I started creating the system design. Then February to March, testing and evaluation will be happen. And in May, the final deployment. So progress from PPRS uh, to IPD. So identify the like I was able to successfully identify the problem, like which is function interaction blindness. Uh, Found that current systems are blind to how different computer actions work together over time to cause harm. And the second one is build a hybrid model, like create a smart two-part system that uses transformers to see big picture and a CNN to catch small specific patterns of malware. And the third one is improve the quality of data, like I remove the logs, I remove duplicate logs, because most of the models, like most of the research papers, they have used duplicate data. So that's another problem that I identified during my research. And uh, and also I used several unique techniques to improve the quality of data. So ingesting, this is what I achieved during my during PPRS to IPD time. This is the accuracy that I got. This is the result that I got for each classes as well. So future work. So in future work, my main goal is to enhance the accuracy, and uh, and I need some. So there's a like since most of the data, I went through several data sets. So most of the data uh, consists, it includes with most of the data have a lot of duplicates. So a lot of error. That's a big error. And I'm looking for more rich behavioral data to enhance my model as well. And throughout this period, I was able to successfully get a decent result by using byte latent transformer and attention mechanism to analyze the API sequences. So So yeah, those are the things. So I'll be those are things that I did during my IPD, during the time between PPRS to IPD. So my main plan is to enhance my model before the main submission. Thank you.